Hey everybody, welcome to the channel. Well, the deal worked out. What a deal it was. I was in Winsboro yesterday on Saturday, down at a flea market down there with my wife, and I got a message from one of my viewers who happens to live in town here, Michael Redmond. Think highly of you, sir. But he said there was an estate sale going on in Monroe, and he said there was a Dumont television, old Dumont TV, they were trying to sell for $25. I immediately dropped everything I had and said, I want it. So by the time I got back into town, they were closed. I had the wrong address anyway. But anyway, Mr. Redmond called and said, hey, this guy wants this thing, can you hold it till tomorrow? And they said yes. Well, anyway, after church today, my wife and I took off over there, and lo and behold, there it was. So Michael, I owe you one, and remember what I told you, it still stands. I've got, you want test equipment, I can fix you a reward for this. Now let's show you what I got. What I have here is a Dumont black and white television. It's called a Clinton. No relation to Bill and Hillary, I hope. But looks like, I guess, about a 17, I reckon. It's really nice. The cabinet is really nice. It's got a little D-lam going on here and there. It's got a little bit of laminate on the side where the speaker is that needs a little bit of work, but all shellac here, I believe, if I understand right. You can wipe this thing down with a little bit of alcohol and it'll clean right back up, I think. Let's see, the on-off volume knob is got a crack right here. Hopefully I can find somebody that's got one. But the biggest thing, and it's really in good shape. I don't see any issues as far as this goes. But this TV set, it's called a Clinton. It was built around 1953. The price was averaged about $380. It's a model number RA 164/165, and they made several different versions of this thing. This one here is I guess you could say a tabletop size, I guess you'd say. Then they had one in just a cabinet, same thing as this, just had a cabinet going down. And then they had another one that had a big wooden cabinet, and I guess it had other things in it. But this dude is heavier than I could pick up. We'll look around at the back in a minute. This dude, about 21 inches wide, about 19 inches tall, and let's do it this way. And about 20, we'll just say 21 inches in depth. Screen size, oh, it was a 17, more like a 15. I guess it's about a 15. So, anyway, let's just have a look at the back. We're going rogue here for a minute, okay? All right, I had to do a little maintenance there. Anyway, here's the back of this dude. And already here looks like the damper diode tube right there, horizontal output, which looks like it went to air. It don't look too good. That's a Westinghouse tube right there. That's a Dumont 6BQ6 Sylvania tube here. That's probably the horizontal oscillator driver. Got a GE in there. That's probably vertical deflection amplifier if I had to guess. Let's see, that's a, I can't read the number of it here, but it's got various makes and model tubes here. But let's look around a little bit here. You notice something that's unnerving right there. You see the little black pieces right there? They're all over this thing. The yoke has apparently disintegrated. We'll look at that in a minute. The set's a little dirty. And this is something I've never seen, an internal antenna for television. And that's pretty cool what they did here. Here's your twin lead right here. Let me make sure this thing. Twin lead right here, and goes into these little aluminum bands that goes up here. And that's pretty slick. Staples come loose. This thing actually is worth repairing, hopefully. We'll just put that out of the way. Ah, hang on, I got a splinter in me. Ugh. Put you down for a second. Sorry about that, got a splinter in me. Well, there's the centering magnets. All that's in place. The ion trap is right here. It's in place. See a Dumont name on the CRT neck. Let's see. Pitch tube is dangerous to handle. Qualified service personnel. Well, I guess that leaves me out. See here, what else can we see? There's model number. Dumont Teleset, Allen trademark. Allen P. Dumont Laboratories, East Patterson, New Jersey, USA. Serial number is 6597659. It's run number 2. Dumont Quality. Whoop, I'm sorry. Dumont Quality Control 27800. This is one of those 30. I think that is. Not sure what that means. I'm not sure what this means. I don't know. 63 seems kind of late for this, but I don't know. 229949. Is that perhaps a date code? If anybody knows what that means, let me know. I'm thinking what, 29th day of November, September 29th of 49. This thing was certified good to go. I guess that's what that might mean. So anyway, let me find the CRT number on here to know the exact one, and we'll get this Encore CRT tester out. And let's see, very first thing we're going to do is we're going to check that CRT. Cross your fingers, guys. Alright. Did a little more research to this thing. I'm trying to get the right view here. Trying to keep my stomach out of there. This CRT is a 17-inch, so this makes this an RA164. The RA165 is a 21-inch. The CRT is either, I can't find the number on the picture of the CRT itself, but it's either a 17KP4 or 17HP4. So we're just going to set it up for 17KP4. So what we're going to do now, first off, I can't see nothing on this. CRT black in there, isn't it? Let me get a light. Should have done this ahead of time. All the light that I got in here is still dark. My version of a man cave. I love coming out here working on this old stuff, but there we go. Now we can see. So reach across from you there. We're going to use, I have two CRT testers. Got a B&K that I don't use much, but I use the Syncor here. it seems to do a good job. I'm sure people's got pros and cons about it. But this thing was free. It was given to me along with a bunch of other Syncor pieces of test equipment, including my prized possession, my little Syncor, sorry about that, LC103. That is my pride and joy. I'm only bragging about it because I never expected to own something like that. So let's look in the manual here. We're looking for 17 PK4 right there. And what I'm going to do is I'm going to write these settings down on this. So if you don't mind, I guess you can stick with me. I'm just making notes. 17 KP4, so we're going to use the universal adapter. Video, of course. And then F1 is 1. And then F2 is 12. That's your filaments. So stupid sometimes. Alright, the filament's going to be 6.3. That's alright. 36 volts, negative bias. Alright, black and white. Alright, the K will be 11. Cathode. G1 will be 2. And G2 will be 10. Now we open up here. Universal adapter right here. Kind of a pain in the butt, but it works once you understand what to do. Because what you basically have to do you have to go and set these a certain way. So let me go back to the front of the manual. CR70 right here, so F1's got to go to 1. So F1 right here, 1. Then F2 is going to be the 2. And then K is going to be 3. So K, 3. And then G1 is going to be 4. And G2 is going to be 5. So all the universal set switches are done. So all we got to do now is very carefully, let's get away from that a minute. Let's see if this will come off without any catastrophe. Alright, so what we do next, never used one of these bad boys before, untwine these cables. All the, oh my gosh, I ate barbecue for lunch, it's killing me. Every one of these leads right here are marked G1, G2, let's see, and it's marked also, if you look right here on G1, it says 4, then G1. That tells you to set G1 switch for 4, the G2 switch for 5. It tells you what to set up, which is really nice of them. Anyway, let's do the filament. Let's do them all. We're going to start at F1, when it needs to go to pin 1. So here's F1. I got to find pin 1 over here, and I don't have my glasses on, so Lord knows what we're going to do. So here's pin 1. That's F1. Then I think pin 12 is F2, wasn't it? Yep, F2 is 12. Okay, got that. Unless they pop off, we're good there. Alright, this is G1. G1 is going to be number 2, so that's right up here next to P1, F1. Got 2 to go. Alright, so far so good. They've got G2, which is pin 5. So this is 1, 2, 3, 4. There is no pin 5. I'm sorry, 10. Don't know how to do this stuff anymore. G2, pin 10. Got that. So the only thing left now is this guy right here, which is the cathode, and the cathode goes to pin 11. Right there. Alright, so let's look at this again. F1 is 1. Okay, that's right. Alright, F2 is going to be 12. That's correct. Let me see here. Filament voltage is going to be 6.3, so we got to set that up. It should still be on 6.3. Filament 6, okay. Negative is going to be 36. It is. Cathode is going to be on pin 11. It is. G1 is going to be on pin 2. There it is on pin 2, and then G2 is on 10. All right, we're ready to go. Let me get you set up. Let's test this bad boy. Gotta make room. Make room so we can see all this mess. Widen you in a little bit. Best I can do. Alright, so let's apply power to it. Where is the, say, video, black and white, cutoff set, filament set. Turn the filament set all the way down, apply power, bring up the filament set till it comes up here to that little red mark up there, which you may or may not be able to see. Are you kidding me? Thought I had this fixed. I've had intermittent trouble with this stupid thing. Thought I had it fixed. Very intermittent. Take it apart and it goes away. Anyway, it'll stay there. Let's go over here to heater to cathode. Oh, hang on. Heater to cathode says it's good. G1 short says it's good. Cut off. Alright, here we go. See if we can find the cutoff switch, because I can't ever find it on this thing. Don't have any cutoff. Have just a little bit. But it says you can have a little bit of cutoff and it will still work. Let's see what the emission is. It's getting higher as we operate it. So sometimes when you run them a little while, they'll get better. So let's just run this thing a little while. See what happens. Make sure the filament's still working. Filament set where I left it. And look, we got cut off. Well, these old sets, this is probably still good. Thing is just wonky. I gotta go find my my other one and see if it works better. Let me go see if I can find that other one. Alright. Now shoot. Hang on. Get everything in right here. So let's put this out of the way. There we go. I have a backup. Have not used this thing, but it's a guess what? B&K Model 466 CRT tester. I've not used this thing. I don't know how good it is. So let's power this thing off. Get rid of this. I think it'll plug in directly. I still got to figure out what's wrong with that CR70. That thing's funky. So let's plug this thing. Let's plug this guy in. Move this. I really thought I had that fixed. I don't know where to put you guys where y'all can see. I really don't know where to put y'all. Let's try that. Yeah, I know, y'all getting vertigo. Alright, well. Let's see what we can do. Anyway. There's the G1 voltage, power off, heater. Does power on. I'm just checking it. I have not used this thing before. So let me just check this thing. It says here, minimum, set to minimum, connect CRT and adjust. Only saying 4.7 up here. I don't know. See what happens. See, this thing's showing low heater voltage. Get it all the way up. See if we got any leakage. No heater to cathode, no G1. The G1 voltage. G1 voltage is number 5. Looking at number 5. I have no idea. I don't know what to set the G1 voltage to, so let's just go up to G2 cutoff voltage. Yeah, this thing's not right either. Okay. Enough of that. One works fine when it works, the other one don't work. I can't get enough filament voltage out of it, so no telling what's wrong with it. It was acting wonky as I was trying to set the cutoff voltage. I didn't know what to set the G1 voltage to on this, so. Anyway, I think the picture tube has got some life in it. It probably will get better as it runs, who knows, so. Let's dig into this a little further. So let me Let me get rid of all this mess off my bench and we'll come up to the next phase of this little thing. Okay, I have the chassis removed from the cabinet. I believe the pitch tube is going to be halfway decent. This is the chassis right here. I had to cut what was left of this insulator off on the second anode right there. So I'm going to have to figure out a way to replace that. Somebody somewhere has got some, let me know. Quite dirty. A little bit of a roughness there to it. Got a little bit of a critter stain or something. That's right about where, wonder if that old rubber just decomposed and melted maybe. 'Cause that's the only spot that I see it. And then of course all this black powder right here, that's all deflection yoke. The back cover, which yoke rod I think that's called. Here is a filter filter choke right here for the power supply. Here's supposed to be one of the main capacitors right here. So paper capacitor right there. It's kind of a chalky, I don't. Another 5U4. It's seen pretty rough lie. Tuner, drum type tuner. Got some issues here. Got a little black tape on there. That didn't look good. It still don't feel good, so that'll probably may have to be redone. I don't know yet. And if I understand right, this is the IF strip right here. All the tuned circuits for the video. I'm assuming this is all video here up to this point. Then this is probably the sound because they're larger coils, if I had to guess. Another filter capacitor right here. Not sure what that tube is back there yet, but there's your AFC phase detector for your sync. Recognize that. Big tube right here, probably video amplifier, sync separator if I had to guess. Not sure what these would be. So kind of straightforward. Here is the high voltage assembly right here. See what it looks like under here if I can figure out how to open it. Looks like it pushes. Yeah, I need two hands or something here. Yes, it is shaky cam. Try to get a look at the flyback in here. Let me get my light. Oh, look at that bumblebee right there. That'll get you. That'll be fun to change. Yeah, the deflection yoke don't. Damn. The flyback don't look bad. There's the high voltage rectifier, or the second anode. Got a 1/4 amp fuse in here somewhere. There it is right there. So that's good, I guess. So the horizontal output, that's went to air, as some people call it. That's a good. So this, I'll shut you off a minute. Let's flip this bad boy and let's see what it looks like underneath that barbecue is kicking my rear end. Bring you right back. Well, I'm halfway surprised. This set has seen some, it's been in some service shops once or twice. This wonderful light I got right here. I'm about to invest in me a Milwaukee battery operated light. Alright, let's have a look at what we got here. Make sure you guys are wide angle. Here's the IF strip right here that's coming out of the tuner. That cable looks mighty deteriorated, but something there that don't look right. Don't know what that is. It's white in color. Right there. I keep pointing the dang, looking at stuff, and the damn camera is somewhere else. Wish I had a shot for every time that did that. Anyway, there's whatever that is. The camera and the lights interfering with each other. Not sure what that's all about. Moving on, let's see, there's an IF strip right here, then it gets down here to the where the sound takeoff is, and then the audio section right here. That's more than likely a discriminator. There's an electrolytic capacitor right there. Y'all know what we'll have to do to that if we make it that far with this. There's a paper cap. Oh boy. 4 microfarad right here, 200 volt, another electrolytic. Big paper cap right here. Let's see, another one right there, and look at these orange drops right there. Oh, look at that orange drop. You don't see that very often. Look right there. See it? It's split. When was the last time you seen an orange drop split? That one is split. I'll be dang. There's one there. It looks alright probably. Let's see, another electrolytic down here, and I love the way they did that. You see they got the wax string around it. Man, that is cool how they did that. That's first time I've ever opened up a Dumont set, okay? I worked on a Dumont oscilloscope, and I had a video on that, one of my early videos. I hope this don't go that way, because that Dumont scope, it just needed more and more and more parts, and I just finally scrapped it and used it for pieces and parts. Let's see what we got here. Got some solder, excess solder here, right there, and got some on right there, which meant they've been inside. Somebody's been soldering on it. Looks like here. Oh, look at there. Somebody cut that cap loose and tacked it back on right there. So wow. Let's see, another paper cap, paper cap, paper cap. Oh, and that's cut loose. Look at there. Yeah, that's going to be so much fun. A tiger. Ooh, look at that big old boy. Another one right here, here. That looks like one stuck down there. Look at these big old dominoes. Right there on the line. What you want to bet we don't use them anymore? I don't trust it. So it's had a lot of cap work in it in its previous days. I see some cutoff right there. I see that. So this resistor's been changed. It's like a little 1 meg. Where you at? See that leg right there? They just cut it off and look like they just pushed it through and left it. Wow. Leg come out of that, so they apparently just pushed this cap through, twisted it around once, and left it like that. So I guess what I want to do, I'm not even gonna, I want to ohm out the deflection yoke and the flyback if I can before I there's no telling what's been done to the set. I would like to pull this 5U4 and those bad air-to-air tubes, and let's see if we've got heater voltage to the rectifiers. We've got plate voltage to the rectifier, and heater voltage and B+. So let's get set up to do that. That'd be the next thing to do. Make sure that this bad boy is okay. Once we verify that bad boy is okay, then we'll move on and check the flyback and the deflection yoke. Then we'll decide what to do from there. So give me a few minutes to get set up. Alright, I've got my test set up. Got the TV set. I'll pull all the broken tubes out. I'll pull the 5U4 rectifier out. So basically we're going to be looking at the filament voltage to the rectifier first, then we'll look at the high voltage, you know, the secondary, high voltage secondary, and then we'll look at the main filaments and see how many tubes are lighting, and just see overall how this thing responds. So I've got it into my dim bulb tester, which is of course connected to my isolated AC power supply. So I'm going to turn it on here, and we're just going to watch the AC voltage. Already getting 0.036 volts. So I'm going to bring it up. I've got about 40 volts primary voltage on it right now. Dim bulb tester is a little bit red. Just kind of watch it. It is dying down a little bit, so it looks like maybe filaments. Let's bring it up a little bit more. Bring it up to about 60 volts. You've got about 1.2 volts, and the dim bulb pretty bright. Interesting. Drawing quite a bit of current. We might lose power here before we get careful. It's starting to rain. So let me have a look at these filaments. I wonder if I missed one. Oh no. Drawing quite a bit of current. I'm going to bring it up about 80 volts. It's dropping quite a bit of current, but I'm up to about 2 volts now on my 5 volt filament. And I'm drawing still about 300 milliamps, so I guess it's not bad. Let's just bring it up full blast. Let's see if 2 filaments are warming up, so that voltage is increasing. That's a positive sign. We'll turn the lights off again and see what tubes are lit up. I see some tube filaments lighting. Okay, I see some. I got to turn this other light off because I still can't see because I'm blinded. Lord have mercy. I'm just looking for filament voltages on stuff. Damper tube is lighting. As far as on the oscillator here, don't look like it's doing anything. We'll pull it out. That didn't really make any difference, but we'll leave it out. Okay, I see 2 filaments. Yeah. Yeah, I've got about 3 volts of something's just drawing a lot of current. Good, y'all hear that? I expect a tree limb to come through this roof any minute now. So I'm drawing almost 25335. I'm throwing about 400 milliamps. I got 3 volts on the filament, on the rectifier filament. So let's see what we got for heat. Transformer's cool. So let's switch over to the primary. I'm sorry, the high voltage secondary. I was really smart, I would use my tube extender. Alright, I am on the high voltage secondary of the transformer, or the high voltage rectifier plate connections. So let's try this again. So I have about 290 right now, going up to 300. And these lights keep messing around, we're going to lose our power. At 330 volts right now, plate to plate. Do this to ground. Let's see what I'm getting plate to plate to ground. I got 162 on this side, unless I'm doing something wrong. I got about 165 on that side, on one side of the plate to ground. And then I got a clip that keeps popping off on the other one. Lovely, lovely. There we go. I got 100 and... So yeah, 165, so it seems to be balanced. Let's go get up there about 165. I don't know what the plate secondary is supposed to be on this set. Let me get my glasses. Oh, this is very small writing. Can't read it. Can y'all? Let me go look on the internet there. Well, that concerns me that I'm pulling so much current with nothing but the tubes on there, but it's probably normal, but I'd rather get the tube draw off of here. So what I'm going to do is I'm going to pull the filament string loose off the transformer. It's a grounded. One side of the filaments is one side of the filament string is grounded. And then the other side is I can't see what I'm doing up there on the, might just clip this. Shake it too hard. There we go. There's my filament. It's a green wire. Alright, I got the filament, the 6.3 filament pulled loose. Alright, it'll just stay pulled loose, will be good. So I'm going to double check. I'm going to double check the current draw. As soon as I get these test leads back on here. Alright, I'm going to start over. Can y'all see the meter? Yeah, Mr. Thunder. I think y'all can see the meter. Anyway, here we go. What I'm looking at, at least I think I'm looking at, is the 5 volts for the 5U4. Oh yeah, the dim bulb tester says everything cool. Not hardly, I'm drawing a little bit of current, but not much. There's a damper tube right here. This filament, this is just another transformer here that powers the damper tube. I'm running at about 4.73 volts. So I'm going to pull the damper tube because I figure it's probably drawing a little bit of current. The power supply says I'm drawing about 0.24 amps. I'm going to pull the damper tube. Like I said, it has a separate power supply transformer. It's right here. It's isolated. Anyway, the damper tube's been pulled. The Dumont tester is slightly glowing. Glowing a little bit. But it's also pulling about 0.15 amps. And my 5 volts is at 4.98. 4.99 volts at 117 volts in through the damn bulb. So I got 5 volts on there. Let's see what the high voltage secondary is doing now. It should be 270 volts plate to plate. I'm sorry, plate to ground and then plate to ground. Yeehaw! Don't y'all love it when the clip leads pop off? You're like, yippee! It's a good way of really giving me the red button. But it's supposed to be nicer than that. Let's turn this over. These little old Chinese leaves don't cut it. Alright, here we go. Yeah, I'm at 275 volts. One plate to ground, so let's check the other side. Should be about the same. Yep, I ain't about to hold this with that plate voltage on there. So it's about 275, so okay, good. Let's go ahead and check the filament while I'm at it. Should be 6.3 volts. And it's reading a little high, 6.6, 6.56. It's going to read a little higher unloaded. Alright. Well, the filament, the power supply transformer seems to be good. At least at this time. If it was bad, this whole set would be just like, no, forget it. So I guess we own out the flyback. We can find the points to do it. So let me see if I can figure out how to do that, and I'll come back with a report. Alright, I'm about to check the resistance of the flyback. According to this slightly exploded printout here, I need to measure from the horizontal output tube to the plate of the rectifier. Should read around, looks like 400 ohms. And then from the plate of the horizontal output tube to the linearity coil should be about 22. And then when I check that, then I'll check all the way down to whatever the hell, the horizontal size coil, and that should be continuity in there too. So let's check all that stuff. I gotta find it. Probably one of these guys right here. So let me get set up here with a little bit different test leads, because them little mini leads just ain't doing the job for me. So let's get set up. Alright. Y'all can see the meter pretty good, huh? Awesome. Alright, I am connecting to the one lead to the horizontal output. Then I'm going to try to get this off. Yeah, I got everything off but what I needed. Alright, I can find my errant test lead, I'm going to go to the cap of the high voltage rectifier. See what we got. I don't see nothing. I'm getting some. It's just not making a good connection, apparently. Still ain't getting nothing. What's up with this thing? Could be open. Got measurements through there. Boy, this ain't going to be good. That's not good at all, is it, guys? I should have around 400 ohms there. Not good at all. I ain't getting nothing. No, I ain't getting anything. And every damn time I move this thinking test lead, it falls off. Not that I'm impatient or nothing. I get a little bit there. No, it's not measuring at all. That's what I consider bad news. Yep, that's what I consider bad news. Should be 400 ohms on the flyback from the horizontal output deflection amp. Horizontal output to plate to the cap of the high voltage rectifier. So let's go the other way and let's go over to the horizontal linearity coil, wherever that may be. No idea. One of these bad boys. Let's just measure this one here. Alright, there's 25 ohms there. That looks right. That's what they're expecting, about 22. Well, that's good. Let's go down to the horizontal size, which is probably going to be this one. I'm getting about 58 ohms. So it's got to go 25 ohms, 25, and then 8 ohms. Yeah. So that's not good. That's not good. You can see this. Right here is the plate. Where is my pointer? Try to do this. There's your plate right there, the horizontal output tube. I was measuring right here. And this is the it's a screwed up schematic. Tell you, let me bring you over to the computer instead of dealing with that stupid paper and no damn flying around in the air. Let me move this over to a screen that we can appreciate. Nah, that's a lot better. Anyway, I was measuring from here through here at 400 ohms right there. Horizontal output plate through the flyback high voltage secondary to right there. That should have been 400 ohms. It was open from here to here, but from here to there was good. So this section of that flyback's open. Yep. That's not a good thing, guys. I really don't know who I could get a flyback for this set from. Alright. So the picture tube is iffy, but I think it'll work. I'm gonna have to work on my cotton picking CRT testers. One of them don't work right at all. The other one has got some kind of intermittent that I just cannot find, because every time I open it up it messes up. So the next thing, anyway, beside the point, I think the CRT will work on this thing, but we definitely need a flyback. The other thing is the yoke. Against my better judgment, I'm going to clean my bench off, put the chassis out of the way. Then I'm going to get the I'm going to put the picture tube and put the cabinet back on the work table and pull the yoke out. And I'm going to ohm the yoke out and inspect it for any kind of potential damage and make sure it ohms out good. Then I'll just have to probably buy a yoke off of somewhere and just use the plastic to fix this one. What I did on the Zenith. So anyway, that's where I'm at. Potential bad news. So let me do the rest of this and I'll come back. Alright. The hits just keep on coming. But first, let's have a look at the yoke. Pull off the support mechanisms right here. These little spring-loaded clamps. I got 2 springs come here with has this little Dumont on the back. I guess that's to keep it pushed up against the anyway, this is the rod I was talking about. There used to be a plastic cover from here down, and it is gone. Looks really rough, doesn't it? I don't even know what the heck that was. I mean, that's got the look of, oh hell. But the biggest bad thing about it is too much. Look at that. I'm not 100% sure that's normal. Let me clean that off and you can get a better view. Well, let's find a place. There you go. That's a good picture of it. I am exactly coming in from the right side at a straight angle with the camera. As you can see, that gun and everything is pointing down. It's pointing at an angle up. I don't think that's supposed to be that way. That is amazing. It could be. I don't know. Somebody tell me. I don't know. Never worked on one this old. I'm going to have to look at that a little closer to see just how in the devil could that have happened. But I see these leads right here, and this could have been done on purpose, because I see these leads. It's hard to see. Them leads right there. If this would have been straight, then that there would have been interfering with this. So this may be normal. So I don't know. Y'all just let me know in the comments what y'all think. The other thing is as close as this is to the neck or to the connections right here. I keep dropping the dang camera. I'm fixed to shoot myself on the foot or something. Anyway, as close as this are, those connections are mighty tight there. It's forced so bad to knock this down like that. I would have thought it broke the CRT. It would have busted it. So that's probably normal. But I got to get in there and look. Let's see if I can do it with zoom. I just don't know. I don't know. Y'all tell me. I don't know. Yes, I've worked on TVs before, but it was all stuff that was later or, you know, more modern than this. So I don't know about this picture tube. So if anybody knows, feel free to let me know in the comments. So anyway, I'm going to pull the yoke out. The yoke is the yoke. It looks like a mess. It actually looks like it's caught on fire, but I know a lot of that's that plastic. But I don't know. Let me get this yoke out and have a look at it, and then I'll think about this. All right, this is the next day here. I just got back home from work. I cleaned the yoke off a little bit there. Got most of that rotten plastic out of there. It looks really rough. It really does. I haven't sprayed it with nothing other than air. But it looks really rough. If I didn't know better, I swear this TV was subjected to moisture. But it looks like it had some chrono dope, or that red dope put on there in certain places, so I don't know. It just looks bad. I think I will the flyback, we need a flyback for it. I know that. Picture tube, the gun on it looked like it was not in line, totally straight. But what I had some people tell me that using these ion traps right here, that's how they did it in those old. The gun is pointed. Let me narrow this up. Like the gun is at an angle, and it's shooting all the electrons straight. So this magnet here, the ion trap right here, basically repoints that beam straight. So it comes out this way, and then this ion trap like comes this way, and then the ion trap changes the direction of the electron beam toward where it needs to go. I figured it would have took a lot of force to bend that gun inside that CRT and would have destroyed the CRT, so I figured it was normal, but I have not seen that before. If I have, I don't remember it. But people told me how it worked, so we're good. So let's get the schematic here. The schematic of this thing, and let's ohm this thing out, and then let's ohm it between the horizontal windings and the vertical windings. And I'll be right back. Now we're going to try this. I'm basically going to ohm out. You can see the ohm meter here. I'm going to turn this around just a little bit. So I'm going to ohm this thing out. Pin 2. I got to find pin 2. I can barely read this. Pin 2 is a green wire. Here's a green wire, so there's pin 2. So we're going to measure pin 2. The schematic right here, the deflection yoke. Let me zoom you out just a skosh. We're just going to ohm this thing out. We're going to ohm the vertical, then we're going to ohm the horizontal, and then we're going to ohm between the vertical and the horizontal to see if any shorts between the two. And then we're going to take the thing and put it on the Syncor analyzer and see if we can get some rings out of it. So here we go. So let's measure from green on the vertical to green and black, which I believe is right next to it. So we're ohming at 666 ohms. So That's 666 ohms, and it says here the windings are 24 ohms apiece. That tells me one of these windings is open. Isn't that interesting? Not quite what I wanted to see. Let's go from, let's do the other one, the red and the yellow. Let's see how the horizontals are. Could be a loose connection in here, but I just kind of doubt it. That's measuring 36.1 ohm, and it says both windings are 18 ohms, so that comes out right. Now let's measure it from one side to the other, and that says it's okay. So let's go back to the vertical side now, go back to the green, pin 2, so pin 1, pin 2. And so far we have good CRT, but one bad flyback and a bad yoke. So here we go. I need to find the green wire. Where does it go? In here. That's black. Green goes up here somewhere. Green wire all the way over here. That little clip, something I hate to hear. Alright, so there's the green wire. Let's see if it's actually making connection. Okay, so it is making connection. So there's the green wire. So it's going to go across the 560 ohm resistor to this side. So now we're looking 644 ohms. So that first coil between 4 and 5 here and here is open. So let's go now from the opposite side. And we have 23 ohms on that one, so that is right. So the problem is between here and here. Luckily, hopefully, it will be just a something that we can fix locally. It's just so nasty in there. So let me shut y'all down for a few minutes. I'm going to get some magnifying stuff, and I'm going to get in here and look really close, see if I can clean this up a little bit. Let me get in here and look real close, and and I'll let you know what I find. All right, this is not good at all. If I can get you in here. But one winding on the vertical side of the deflection yoke is open. And if you look right there, see that little black spot? That is burnt. I could actually see the copper burnt into right there. So this thing had a catastrophic failure, and I'm not sure I can even salvage this. I don't think so, because you can see the Corona dope that's been put on here. See all that violet, purple looking stuff right there all over the place? That's Corona dope. But this thing has had internal failures, and it is burnt pretty good in there. Don't know if I can dig that winding out and perhaps fix it. I don't know, but because I need a flyback, and the way this, just as bad as this thing looks, yeah, it's burnt right here too. I think this set's going to go in hiatus for a while until I can find parts or decide what I'm going to do with it, which is a heartbreak. I really wanted to get this TV going, but it's been rode hard and put up wet. It's apparently been stored in a very bad atmosphere. So that's not good. Let me get my arm out of the way, the hand out of the way. So I can't do anything else with this TV. I sure was hoping that the flyback and all that stuff was good. I guess sooner or later, you know, I'll hook up the right person that may have a yoke and a flyback that I can put in this thing. We can get it going then. But that's it. Now it's just bad news for the set. I'd rather had it been a bad power transformer. At least I could find something that would work. But gonna be hard. I can't pick up the phone and call my dealer anymore. So that's that with this. I appreciate you guys watching. If I find some stuff, I'll update you on that, and we'll make a video of it. But I thank you guys for watching, and we'll talk to y'all later. And if you haven't done so, please subscribe and hit that like button, and we'll go from there. Thank you guys for watching very much, and we'll see you on the next one. God bless.